All right, so very, very minimal idea of what a power series is simply using our infinite series as an actual function. So we'll have a variable that we can actually change and put in different number. We can plug something in and get something else out. If this converges, and now we don't know if it converges because we're changing the actual power series. We're changing it whenever we put in a different x value. So to figure out what x values are allowed so that this thing does converge, we have to find the interval of convergence. So, and we do that usually by using the ratio test. So I'm going to start using the ratio test. So to find the interval of convergence, we use the ratio test. So to start out the ratio test, we first want to look at a sub n plus 1 divided by a sub n, and we do need the absolute values. And normally what I do is I write down this with an n plus 1 in it, and then for the a sub n, I just take this and flip it over and multiply. So that's what I'm doing all in one step. Something to be careful of is when I have this, don't just write 2n plus 1. That's incorrect. We want to have to distribute that too, so make sure you don't mess that up. So there we go, and now I have my absolute values. Now I'm going to look at that. I'm going to look at that and I'll simplify that, and I'll do that over here. And then I'll also simplify that. But that one I think is a little bit more easy to understand. So let's take a look at this. First, what I'm going to do is distribute the 2 in there. So I have 2n plus 2. And then all of that, I'm taking like using the factorial on that. So what the heck is this? Well, factorial means you're just taking this number and then multiplying by every number below that. So what I do is I just take this and subtract 1. So that's 2n plus 2 times 2n, well, if I take away 1, 2n plus 2 minus 1 is just 2n plus 1. And then I just continue, and then I subtract 1 again, and I get 2n. Now if I subtract 1, that'll be 2n minus 1, 2n minus 2, 2n minus 3, and so forth. So really, I can stop it right there. And there's a reason why I'm doing that, because now I can cancel that with that. So I just took it down until I got the 2n. And you can always do that. You can always do that, simplify that way. So I'll change that. This part is what, x to the 2n plus 2, which is the same thing as x to the 2n times x squared. So I'll change that, so now I can cancel it out with that. So let me rewrite that, and then write this top part 2n, maybe I'll do it in black. So I have the absolute value of this. Remember, I'm doing the ratio test, so I'm figuring this out, and then I'll take the limit of this, and then I'll see which x values allow this limit to be less than 1, because for the ratio test, that's what allows us to know that the series converges. So that cancels out with that cancels out with that, and I'm left with this right here. And I always, I mean, I don't write it down, but I think of it like this. I always kind of separate the terms with an n and then separate the x squared, because really when I take the limit as n approaches infinity, it's only going to affect this part of my absolute value. So it doesn't even matter, but I know that this part, since there's no n in the top, the bottom, well, that's going to infinity, and that's also going to infinity. So this whole entire fraction goes to 0. Well, I just figured out that goes to 0. But that's always less than 1. Remember, our ratio test requires that if we want the series to converge, then we should get something that's less than 1. Well, this one, it doesn't matter what x you plug in. You're always going to get 0 when you take the limit of it. So this one converges for any value of x, because no matter what you plug in, you're always going to get the limit tending towards 0. So what we can say here is the interval of convergence, that's going to be equal to negative infinity all the way to infinity, because the limit, no matter what x value you have, is always going to be less than 1 because the limit went to 0. So that's the interval of convergence. That means this one's the most powerful outcome because you can actually plug in anything you want there, and this will always converge. So that's kind of nice. All right. Next example in the next video.